Good day, everyone. Today, we're diving into the a priori algorithm, a powerful technique used in data mining to find frequent item sets and discover interesting relationships among large sets of data. So, let us know what is a priori algorithm. The a priori algorithm is a classic algorithm used to find frequent item sets and generate association rules from transactional data. It was developed by Rakesh Agrawal and Ramakrishnan Shrikant in 1994. The goal of a priori is to uncover interesting patterns between different items within large databases. So why is it called a priori? It is because it uses the a priori principle, the idea that all subsets of a frequent item set must also be frequent. This principle allows the algorithm to prune unpromising item combinations early, making the process more efficient. For example, if milk and bread is frequent, then milk and bread must be frequent individually. How the algorithm works. First is data collection. We gather all the transaction data, and each transaction lists the items bought together. This forms the database we will analyze. Next is prune. Before joining items, we apply the pruning step. Remove any items or item set that clearly cannot meet the minimum support threshold based on previous results. This step reduces unnecessary combinations early. Next is join. After pruning, we join the remaining frequent item sets together to form larger candidates item sets. For example, we combine single items into pairs, pairs into triples, and so on. Next is test support. For each candidate item set generated, we test its support. We check how often it appears across all transactions. Next is below support, and go back to prune. If a candidate's support is below the minimum threshold, it is discarded. The process goes back to prune and removes these weak item sets. Next is above support to frequent item set. If a candidate's support is above the threshold, it is accepted as a frequent item set. These frequent item sets are saved for generating final rules. Next is frequent item set to prune and repeat. Using the new frequent item sets, the algorithm prunes again and attempts to join larger combinations. This cycle of prune to join to test support repeats. The last is terminate. The algorithm terminates when no further frequent item sets can be generated. At this point, the discovered frequent item sets can be used to create association rules. Here are the important metrics of a priori algorithm. Support. It helps you find common patterns. If an item set has low support, it might not be interesting because it happens very rarely. For example, if milk and bread appears in 2 out of 4 transactions, the support is 2 out of 4 is equal to zero point 0.5 or 50%. Next is confidence. It tells you how strong the rule is. A high confidence means when X happens, Y also happens most of the time. For example, if milk and bread appear together in 2 transactions and milk appears in 3 transactions, then confidence is milk is to bread is equal to 2 out of 3. That means it has 66.7%. Next is lift. It shows whether X and Y happen together more than expected. For example, if bread appears in 3 out of 4 transactions, the support is equal to 0.75 and the confidence of milk to bread is 0.67. Then the lift would be 0.67 over 0.75 is equal to 0.89, meaning milk and bread are slightly less associated than random. Let's consider this simple transaction dataset. Each transaction includes items like milk, bread, diaper, and beer. Our goal is to analyze this data to find which items are frequently purchased together. To make it easier to understand, here is a sample code of my application that demonstrates the a priori algorithm effectively. First is to set up and basic interface. Flat is a library for building GUIs in Python. Iter tools helps create combinations, which is important for generating association rules later. Next is main app structure. This function designs the app's page, setting its title and scroll behavior. Next is input fields. Transaction input where the users types multiple transactions. Mean support input. Minimum threshold for support. Mean confidence input. Minimum threshold for confidence. Next is the output. A text box to display the results after running the a priori algorithm. Next, parse the transaction. This function reads user input. It splits each line and separates items by commas. Returns a list of transactions. Each transaction is a list of items. Next is to calculate support. Counts how often a given combination of items appears inside the transactions. Divides it by total transactions to calculate support as percentage. Next is the a priori algorithm logic. Finds frequent item set. Groups of items that meet the minimum support threshold. Starts with single items, then builds bigger combinations. Only keeps combinations that are frequent. Uses a loop to generate larger item sets until no more frequent sets are found. Next is to generate association rules. After finding frequent item sets, we create rules like if milk is bought, then bread is likely bought too. It calculates confidence or how strong the rule is and keeps only those rules that meet the mean confidence threshold. For example, if the confidence of milk to bread is 80% and the mean confidence of 70%, it is accepted. Next is to run a priori when button is clicked. When the user clicks run a priori, it parses the transactions, reads minimum support and confidence values, runs the a priori function to find frequent item sets, runs generate rules function to find association rules, displays the results inside the output text field. Next is the button and the page layout. Adds a button for users to trigger the a priori algorithm. Adds all input fields, button, and output to the page layout. Lastly is to run the app. It launches the app, making it ready for users to interact with. After running the app, this is now the output. This app uses Flat to build a simple graphical user interface. Inside the GUI, you can input transactions, set minimum support and minimum confidence, and then click Run a priori to analyze the data. Below the Run a priori button, you can now see the frequent item sets that has been transacted, and then its association rules. So why is this app connected to a priori? The a priori algorithm works by finding frequent patterns or item sets and then building association rules from them. It allows users to experiment with real transaction data and see frequent combinations and strong rules. Here are some real-world applications that uses the a priori algorithm. In Amazon, it has 70% of users who buy a laptop also buy a mouse. In short, a priori is very practical and widely used today. In conclusion, the priori algorithm is a powerful tool in the world of data mining. It helps businesses and researchers uncover hidden patterns and relationships between items in large datasets. By analyzing transactions, a priori can reveal valuable insights, such as which products are often bought together, helping companies improve marketing strategies, boost sales, and enhance customer satisfaction. A priori systematically scans through transactional data to find combinations of items that occur frequently together. It uses metrics like support, confidence, and lift to ensure that the patterns found are both common and reliable. These patterns might not be obvious at first glance, but a priori brings them to light, turning raw data into actionable knowledge. Below is the references where I have gathered informations to share it with you. That's all, and thank you very much for your time and attention. I hope this discussion helped you better understand how the a priori algorithm works and why it is so important in real world applications. Your curiosity and engagement are truly appreciated. Thank you.